we will be discussing velocities, both linear velocity and angular velocity. If a point P on a circle of radius r moves a distance s, then the linear velocity is given by the formula v is equal to s divided by t. If the point P is moving with uniform circular motion, then the angular velocity is given by omega, or angular velocity, is equal to theta divided by time. If a point P moves on a uniform circular motion on a circle, then the linear velocity and angular velocity are related by the formula v equals r omega. And what you want to know is 1 revolution is equal to 2 pi radians. We want to find the linear velocity. S equals 10 feet and t equals 2 feet. So we know v is equal to s divided by t. So v is equal to 10 divided by 2. V is equal to 5 feet per minute. Find the distance covered by a point moving 10 feet per second for 4 seconds. So we're given our velocity. Velocity is equal to 10 feet per second. Time is 4 seconds. We know that v is equal to s divided by t. So 10 is equal to s divided by 4. 40 in units would be feet is equal to s. So the distance covered would be 40 feet. Find the angular velocity of point P if theta is equal to 12 pi and t is equal to 5 pi. So again, we want theta to be in radians, which we have. We know the angular velocity is equal to theta divided by time. Omega is equal to 12 pi divided by 5 pi. Simplifying, omega is equal to 2.4. Convert 16 2/3 RPMs to radians per minute. So 16 2/3 revolutions per minute times 1 revolution is equivalent to 2 pi radians. I'm going to put RAD for radians. The revolutions, the word cancels out. This is unit dimensional analysis. So if we change that, that's 50 over 3 times 2 pi over 1. Which is equal to 100 pi over 3. And that would be radians per minute. As a mixed numeral, it would be 33 1/3 pi radians per minute. And then we could also get a decimal, approximately 104.47 radians per minute. All right, so let's look at the next one. Find omega if r is 6 and v is 3. So we know v is equal to r omega. So 3 is equal to 6 times omega. Divide by 6, you get 1/2 is equal to omega. So omega is 1/2, or we could do 0.5 as a decimal, radians per second. Number 6, a gasoline-driven lawnmower has a blade that extends 1 foot from its center. The tip of the lawnmower blade travels 1,100 feet per second. Through how many revolutions per minute does the blade turn? So we're looking for angular velocity here. So we know that v is equal to r omega. So v, which is 1,100, and this is feet per second, is equal to r, which is 1 foot, times omega. So our feet units divide out. So 1,100, and again, this is going to be radians per second, is equal to omega. And if we check our answer, the question that asks us says through how many revolutions per minute? Well, my units are radians and seconds, so I have to convert seconds to minutes and radians to revolutions. So we know 1100 radians per second. So we know that there are 60 seconds in 1 minute. And we also know that 1 revolution is equivalent to 2 pi radians. And I paused for a moment there to see where the radians were. So see, these units will cancel. The second units will cancel. And so what we have when we do the math is we have 33,000 divided by pi revolutions per minute. And we can get a decimal. This is how the answer was given in the example I found. But remember that your theta needs to be in radians as we work through not only angular velocity here, but from our last lesson, arc length and area of the sector. Have a great day.